Hello, my name is Adam Rice, and I'm the leader of Team 5, and this is our mid-semester presentation. This presentation will cover our progress on the needs statement, analysis of alternatives, concept of operations, system requirements, functional analysis, and the SWOT analysis of our project. Our project focuses on ladder fall prevention. The goal of the project is to evaluate possible product concepts, select the best solution, and develop a business plan for that product. Up first is the needs analysis. Each year in the United States, approximately 500,000 people are treated in emergency rooms for ladder-related injuries, and about 300 of those injuries are fatal. The Occupational Safety and Health Administration estimates a single non-fatal ladder injury costs the employer an average of $41,000. A fatal accident averages $1.2 million in worker compensation and administrative costs. Ladder injuries in the United States create a total financial burden of approximately $24 billion annually. These injuries often occur during common household and work-related tasks, making ladder safety a widespread concern for both homeowners and professionals. Accidents happen during activities like performing construction tasks or maintaining a home. Because these tasks are so common, the number of people exposed to ladder hazards is very large. A major issue with ladder use is that unsafe conditions may not be obvious to the user. The ladder may appear stable at first, but turn out to be at an unsafe angle, loaded unevenly, or beginning to shift during use. By the time the user recognizes the problem, it may already be too late to correct it safely. There is a clear need for an improved ladder fall protection solution that helps users recognize unsafe conditions, maintain proper stability, and reduce the likelihood of falls before they happen. A successful solution should be simple to use, affordable, compatible with common ladder types, and effective at reducing injuries and deaths associated with ladder use. Now we'll take a look at some of the products the team came up with. Concept number 1 is an electronic monitoring system that mounts to a user's existing ladder. This system will ensure a safe setup angle, monitor weight distribution to prevent tipping, and provide audible and visual indicators if the condition becomes unsafe. The advantage of this approach is that it adds safety features without requiring the customer to buy a completely new ladder. It also gives the user real-time feedback during both setup and use. Concept number 2 is an attached mechanical arm which will swing out and catch the ladder if it starts to tip. This concept is simple and does not require complex software or even batteries to be effective. Because it is purely mechanical, it may also be easier to manufacture and easier for users to understand. However, the concept reacts after the ladder has already begun to move, instead of warning the user before the unsafe condition occurs. Concept number 3 is a fully integrated smart ladder. Technology similar to Concept 1 would ensure a safe setup angle, monitor weight distribution, and provide audible and visual alarms if conditions become unsafe. This concept could be very effective because the sensors and warning system would be built directly into the ladder. This concept, however, would require the purchase of a new ladder. While this is the most elegant solution, it will also be the most expensive and may have a lower adoption rate because many customers already own ladders. After analyzing the different concepts, the team decided concept number 1 would provide the best balance of effectiveness, cost, and usability. It will recognize and make the user aware of an unsafe condition before the ladder moves, helping prevent the accident before it happens. This system is also intended to work with a variety of ladder sizes and be installed on the customer's existing ladder. Because Concept 1 is an add-on product, it has the potential to be more affordable and more accessible than a fully integrated smart ladder. It also provides more prevention value than a purely mechanical stabilizing arm because it alerts the user before the ladder becomes dangerously unstable. For these reasons, our team selected the electronic monitoring system as the preferred concept to continue developing.
Hello, everyone. My name is Mohammed Aramithi from Team 5. Today, I will be talking about the concept of operations and the functional analysis. First, the concept of operations. So our goal for our product is to improve the ladder fall safety prevention system and to improve the ladder's safety before and during use. Instead of waiting until the ladder becomes unstable, our system continuously checks whether it is being safely used or not. When a user needs to use the ladder, they simply place it wherever they want to work, and turn on the monitoring unit. Since it is permanently attached, it doesn't need any extra setup required or anything. Before the user starts climbing, the system checks that all 4 feet are properly contacted with the ground. And if everything is safe, a green indicator lets the user know that it's ready to use. If the ladder is in uneven grounds or positioned at a wrong angle, the system immediately alerts the user using warning lights and audible alarms. This allows the ladder to be repositioned before anyone climbs to prevent any falls. Once the user begins working, the system continuously monitors the ladder, and if it detects any unsafe movements or instability while the ladder is being used, it immediately warns the user so they can safely stop working before any accidents happen. When the job is complete, the user turns off the device and stores the ladder because the system stays mounted on the ladder. It's always ready to use for the next time.
Hello, my name is Said Bohorkis, and today I'll also be sharing our team's system requirements for the ladder. So when we were developing the system requirements, we considered the SMART diagram to guide us in our ideas of how we want our system to operate. So this was what was included was one example was being the ladder angle having a safe range of 70 and 80 degrees so that it has a safe range for opening to let the user know to climb onto. We also added a detection system to let the user know that the system is well grounded. So as soon as the user stands upon it, it'll sense a weight of like of a minimum of 5 degrees, knowing that it's easy to use. But if there's something that goes wrong, there will also be a trigger warning within half a second to let the user know that it's not yet ready, you need to be on and it needs to stabilize. We'll also give a visual warning of greater than 50 CD, which will allow the user to have a visible detection of from 10 meters in daylight. We also considered having a battery that will last greater than 8 hours with continuous usage, so that the user would not worry about having to like consistently charge within a short period of time. Then the system also has then the system adds a less than 2 pounds and does not interfere with the lettering. Yeah, in the device, as we mentioned before, is like gonna be like no greater than 2 pounds, so that way it does not interfere with the overall weight of the ladder being in use. And then we also have the system making sure that the device itself not being greater than or at least the maximum being $100 per unit. And then finally, when we considered what we need for the system is that it will remain functional after being dropped from a height of 1.5 meters, and will be have a really good water resistance of at least 1 IPX6, which means that it'll be able to resist just even like let's say a glass of water or something, then will drop on it somehow, and that it'll be fine as long as it's properly cleaned up. And yeah, that's all that I have for the system requirements.
Functional analysis, the functional flow block diagram. The process starts by installing the pressure pads and the monitoring unit onto the ladder. Once everything is connected, the system is powered on and performs its initial setup. The system then performs 3 different and important checks at the same time. First, it measures the pressure on each ladder foot to make sure that the weight is evenly distributed. Second is it measures the ladder's angle to verify that it's within the safe operating range. Third, it checks that all 4 feet are making proper contact with the ground. After collecting all that information, the system combines all three results to determine whether the ladder is safe to use or not. If all safety conditions are met, the user receives a safe indicator uh, and can begin climbing. If it is unsafe, the system immediately provides warning uh, and instructs the user to reposition the ladder before climbing. This process continues while the ladder is in use, allowing the system to monitor stability until the job is finished. And that is it for my section. Thanks so much.
Hello, my name is Braden Frantic, and I will be performing the SWOT analysis for our company and our product. Starting with our strengths. Our company will always put the customer first. Our product will be designed with the customer in mind, our prices made with the customer's ability to buy it in mind, everything. And in doing so, we believe that we will stand out amongst our competitors as the more affordable, more consumer-friendly option. Moving on to weaknesses now. Our product is battery powered, and that comes with its own set of weaknesses. The main one we're interested in is the fact that the battery could die in the middle of use. If that were to occur, then our user would be put in an immediate health risk, as they wouldn't know if the ladder was about to topple or not. Additionally, repair costs would cost much more, as electronic parts are much harder to repair than mechanical ones. These are the two biggest weaknesses that should be taken into account when making and designing our product. Moving on to opportunities. Homeowners and contractors especially would see the most benefit out of using our product as they use ladders the most. Additionally, a partnership with a ladder manufacturer could see a large benefit for both parties involved as they could be sold together. And lastly, threats. The biggest threat to our company would be a change in safety regulations. If our product originally met the safety regulations and now no longer meets those regulations, then we'd have to completely change the design. Furthermore, if a lawsuit were to be filed for our product malfunctioning or failing in any way, then we could lose a lot of trust in our consumers, which is our entire strength. So at the end of our SWOT analysis, three major conclusions can be drawn. First and foremost, our customer-first business model is our biggest strength by far. It is going to be the reason why we are not only able to attract customers, but also to attract potential business offers from other manufacturers. Secondly, this product has to be tested not just for effectiveness, but also for how reliably it can operate at a low battery level, at a low durability, and more. And three, not only should this product be tested to meet regulations, but to exceed them. This way, if safety regulations are changed in the future, we won't have to worry as much about redesigning our product,